Okay, so we're looking at question 7 of the 2012 exam. So we're given an LP problem that has the following final tableau. Now this problem has an optimal solution at two corners of the feasible region, and we aim to find the coordinates of these corners. So firstly, we notice that in the Z row down here, we have no negative entries, so we can stop the simplex algorithm if we like. But something else to notice is that we have a 0 in the Z row in a non-basic variable column. So we can perform one more pivot using x2 in this case as the entering variable. But for the moment, what we'll do is we'll find the first of these optimal solutions. So we can see that x1 has a value of 5 here. So we'll write that. And x2 does not make an appearance here, so we can say that x2 equals 0. So this corresponds to the coordinates 5, 0. Okay, now we're looking to use x2 as the entering variable, and we have to pivot on either 7 or minus 5. In this case, we will pivot on the element 7, purely because the ratio 8 on 7 is a non-negative ratio. We're after the smallest non-negative ratio, but 5 on negative 5 is a negative ratio, so 7 will be our pivot element. So x2 we can see is the entering variable, and s1 will be the departing variable. Now I'll just quickly draw up a table. Okay, so here's our table, and now we notice that x2 is the entering variable here in place of s1, and x1 is the other basic variable. So for these entries, we can quickly write in the zeros, corresponding zeros and ones. Okay, now, so firstly we can notice that this 7 turns into a 1, so what we have to do to this row is divide the whole row by 7. So these entries are 1 on 7, 2 on 7, and 8 on 7. Now for the next step, we notice that minus 5 turns into a 0. So the simplex algorithm says that we have to add 5 copies of this row to this row. So we're adding 5 copies of 1 on 7 to 0 here for this entry, so that's 5 on 7. Now we're adding 5 copies of 2 on 7, which is 10 on 7, to 4 in this case, which is 10 on 7 plus 28 on 7, which equals 38 on 7. So that's this entry here. Now finally, we're adding 5 copies of 8 on 7, which is 40 on 7, to 5. And that equals 35 on 7, which finally equals 75 on 7. Now the final step is to look at the Z row here, and in this case we actually have to add 0 copies of this row to the original Z row, so that ends up being itself. So we've finished our tableau here. Now we can find the second set of coordinates for the optimal solution. In this case, we can see that x1 equals 75 on 7, and x2 equals 8 on 7. And that corresponds to the coordinates 75 on 7, 8 on 7. Okay, so we've found the two coordinates where the optimal solution occurs, so we'll just write this down formally. So z equals 11 at the coordinates 5, 0, and 75 on 7, 8 on 7. And we're done.